Hello children, welcome back to our physics class. I hope you're all doing well and ready to learn something exciting today. Well, in today's class we are going to learn regarding the characteristics of the image formed by a plane mirror and the formula for the angle of deviation. Not only this, we shall also discuss on the different types of images and objects, that is virtual image, virtual object and real object. So let us begin with the first is all about the formula for the angle of deviation. Due to reflection. Formula for the angle of deviation due to reflection. For this, let us consider a plane mirror. Let n be the normal drawn to this plane surface. Okay, so this be some n. Let us imagine an incident ray. So this must be your incident ray and here it must be your reflected ray. Okay, this is your incident ray and here is your reflected ray. The angle made by the incident ray with the normal reaction is called as angle of incidence, whereas the angle made by the reflected ray with the normal drawn to the surface is called as angle of reflection. Suppose if the incident ray is not reflected back, then what would have happened? It would have traveled in this particular direction, isn't it? So instead of this light ray traveling straight ahead to the other medium, this is medium 1, here is your medium 1 and this must be medium 2. So this light ray, instead of traveling straight ahead into the second medium, at this surface, at the point of incidence, it deviates its path. So instead of going like that, it deviates its path and reflects back into the same medium, comes back into the same medium. Actually, it has to go straight ahead. As the medium changes, it is reflected back. So the angle with which the light ray has deviated its path from here to here, this particular angle is called as your angle of deviation. And this angle of deviation is generally indicated with the letter d or delta. D or delta. Okay. So both are same. So this angle itself is called as your angle of deviation. Now let us try to find out the value of angle of deviation in terms of I and R. Okay. So children, if you observe the picture carefully, we see that this is a straight line. From here again to completely, this must be a straight line. For if you measure a straight line, the angle made by a straight line is always equals to 180 degrees. Okay, this straight line must prove value must be equals to 180 degrees. That means, so in this 180 degrees, what are all the angles that are lying? So first one is angle I, second one is angle R and the third one is all about angle D. So if you focus on this carefully, here it must be angle I, angle R and this angle D together 1 plus 2 plus 3 must be equals to altogether 180 degrees. Let me write the same. So, we observe that from the picture I plus R plus angle D must be equals to 180 degrees. But from the laws of reflection, we know that angle I must be equals to angle R. Okay. So, wherever we find the value of R, it can be replaced with I. So, the equation 1 can be rewritten as angle I plus, instead of angle R, I can take angle I. Once again, R is replaced with I plus angle D must be equals to 180 degrees. Okay. What is angle I plus angle I? This implies 2 times of angle I plus angle D must be equals to 180 degrees, or angle D is found to be 180 degrees, bringing the 2I the other side. So, either you write 2 times of angle I or simply 2I makes the same sense. So, angle of deviation D is equals to 180 degrees. I will be simply writing this, children. Okay, 2 ways I will write. Or in other way, simple terms, D is equals to 180 degrees minus 2I, where D indicates the angle of deviation, I indicates the angle of incidence. So, the formula for angle of deviation is found to be D is equals to 180 minus 2I. To be remembered, children, most important formula. So, angle of deviation is equals to 180 minus 2I. So, we observe that D is equals to 180 minus 2I. Okay. This 180 can also be written as instead of 180, we can replace the same with pi. So, pi minus 2I. Sometimes it can be written as pi minus 2I. 90 can be written as pi by 2, 180 is pi by pi and 360 as 2 pi. Okay. Well, so let me also add upon one more concept for this, children, regarding the reflections made on the two plane mirrors inclined at an angle theta. Okay, when two plane mirrors are inclined at an angle theta, some number of multiple reflections are being observed based on the angle. So, for this, let us consider the same, children. So, let us consider two plane mirrors are inclined at an angle theta as shown in the figure. Let this be two plane mirrors inclined at an angle theta. On this, let us suppose that a light ray is incident on this. This is your incident light ray, and here must be a reflected light ray. Again, as it falls on the mirror, normal drawn to this. Here also let me plot a normal. Let us mark this normal as n1 and this normal be some n2. Okay. So, on this, this is your incident light ray. Okay. First incident ray, let me name it as I1, and this is the angle made by the incident light ray with the normal, and this must be your angle of refraction, some same alpha. Again, this will be, this light ray is again re-incident on the mirror 2. This is mirror 1 and here be mirror 2. So, this light ray after reflection falls on the second mirror. On the second mirror, again it is reflected into the same medium as shown in figure. Okay. This light ray reflected, again reflected back. So based on that, let us suppose that this is being incident at some angle beta and also incident at some angle beta. Okay, if this happens to be alpha, then interior opposite angles, this will be alpha, and here also it will be alpha. Okay, forget about it. So like this it is being given, children. So based on that, if you would like to find out the deviation produced by the reflection, some amount of deviation is being produced. This was the incident ray going here instead of straight going. It is again reflected back. So how much deviation it is being observed means it is based on the deviation as equals to, depends upon the number of reflections. So in this example I have only went with two reflections, reflection 1 and reflection 2. But if it happens to be a larger mirror, the same thing can be caused that on the another part, and again it might be reflected, re-reflection. So multiple reflections can take place. Let us suppose that n number of reflections are observed. Then the angle of deviation is found to be n times of 180 minus theta. This is the formula. Here n is the number of reflections, n number of reflections. The same thing, suppose in this example whatever we have considered only two reflections, then d must be equals to 2 times of 180 minus theta. If the number of reflections are only 2, then the formula for the deviation will be equals to 2 times of 180 minus 2 theta. Or d is equals to 360 degrees minus 2 theta. Same, both are same, 360 minus 2 theta. So try to remember, children, this formula is helpful for solving few numericals. Okay. Well, so let us move to the next concept, that is concept number 2a. So where we will be discussing something regarding the types of images and types of objects. Types of images are like virtual image, real image, virtual object, real object, as well as the characteristics of this plane mirror. Okay.